Welcome to Spring LIB.
In part A of problem 60, chapter relativity, we can write a delta t dash time in a S dash frame using a Lorentz transformation, that is gamma into delta t in S frame minus a beta times delta x in S frame over the speed of light, which is a constant, so c square. We can write delta t as a function of a beta by just plugging in the values of a time and a delta x. Here then this becomes a gamma. The time we have 1 microsecond, so 1 minus, and the delta x we have is 240, so then this will become eventually 0.8 beta. In part B, we are asked to plot delta t versus beta for the value of a beta which is greater than 0, so greater than 0, but less than 0.01. So if I plot the graph here, if I plug this beta here and delta t here, if I have the maximum value here 0.01, then my graph will look like this. We'll go down, and here we have delta t dash. In part C, we are asked to plot for the beta value which is less than 1 and greater than 0.1. So we will plot the graph here. So the beta will be x-axis here. So let's say this is a maximum value 1, and so this is let's say here we have a 0.2, and here we have a delta t. Then the graph will go down a little bit and will cross the x-axis 0 and then shoot up near 1. Part D, the minimum value of a delta t can be found by taking a derivative with respect to beta of the equation that we obtained in part A, this equation. So if we take the derivative and set it is equal to 0, then we get gamma 3 beta delta t minus delta x over c. This doesn't look like a c, so it's, sorry, now it's c. Okay, so if we set this equation is equal to 0 and plug the values of a delta x and delta t and a gamma, and then we solve for a beta, then the beta we here obtain is 0.801. So and then we substitute in part E, we are asked to find delta t. So we will substitute beta that we just obtained into this equation. Then our delta t will become 0.59999 microseconds. Part F, yes. So the events, they will affect each other because the speed is lesser than the speed of light. So any event that happens at a point, so the event A, the causality will go from event A to event B, and these events are called time-like events. Event B. End of the problem.